Hey, hello everyone. Welcome to this session. I hope you are doing well. In this section, I'm going to show you about how to use Airflow and how to load data into a PostgreSDB. But before, I'm going to introduce myself. My name is Juan Escobar. I'm a data engineer. I have 8 years of experience, which are divided into 4 years participating in software engineer projects, and 4 years working with projects and applications related to data management and administration. I'm from Medellin, Colombia, and some of my hobbies are the motocross, the tennis, soccer, watch some movies or series, share different fun moments with my friends or my family. And you can find me in the different social media, like for example, LinkedIn, Instagram, Facebook, and Slack. Okay. At the end of this course, of this session, you will be able to get the fundamentals of Airflow. I'll explain such as what is Airflow, why Airflow, how does Airflow work, how the scheduler and the web server work. Then you will obtain the basis to create your first DAG through a guide demonstration on a based example of data extraction, transformation, and loading. And at the end, you will learn some concepts, tips, and good implementation practices through Airflow. Well, this is our schedule for this section. In this section, I'm going to share with you some topics, like, for example, some concepts of Airflow theory. I'm going to explain about what is Airflow, why Airflow, how does Airflow work, what is a DAG, what is an operator, and then we are going to 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 do a quick tour of Airflow UI, and after that, we are going to create our first DAG. I'm going to demonstrate how to load uh, data from a CSV file to a Postgres database, and you will you will learn about how to run or debug a DAG. And at the end, I'm going to share you some practices and tips about how create your first DAG and so on. Okay. So now I'm going to start with the Airflow theory. Our first concept is why Airflow? Why should I use Airflow? Okay. Why you need Airflow in your data stack? So let me give you some use cases. Let's imagine that you have the following data in three tasks: download data, process data, and store data. And your data pipeline is going to be triggered every day at 8 a.m. Now, let's say that download data interact with the API tool. The process data runs a job in the Spark cluster, and the store data operator insert or update data in your database. So as you can see in this image, at each step, you interact another tool with a tool that is knowing your data pipeline and API processing from our database and so on. Now, sorry, what happen if, for example, some of our task, our servers or tools, external tools fails? Imagine that, for example, one server of your Spark cluster failed for memory, for over memory use, or your database is not reachable anymore. As you can see in this example, mm, each step you can end up with an error, but that's not all. What if you have more of one data pipeline to monitor at the same time and thousands of tasks as monitor as well here in Airflow? So the real question here is, if you don't use the correct tool to do that, it will become a real nightmare for you. Okay? Well, Airflow is exactly meant to help you with that. In conclusion, you have to match data pipelines to monitor, to schedule. Airflow will help you and it will save you a lot of time. So that's the reason for that you should use Airflow. Okay, so now I'm going to explain you what is Airflow. The basic definition for Airflow is Apache Airflow is an open source platform to programmatically author, schedule, and monitoring workflows. In other words, Airflow is the best orchestrator to run your tasks, data pipelines in right way, in right order, and at the right time. For example, when you had multiple tools, like for example, Kafka, Spark, Hive Database, and a data lake, you will need Airflow to orchestrate all of those tools and build or run your data pipeline. The benefits of Airflow are Airflow is dynamic. All data pipelines that you are going to create are dynamic. That means that everything that you can do in Python, you can implement in your data pipelines. Airflow is powerful. Airflow provides unlimited possibilities to implement data pipelines with Python. Airflow is scalable. You can execute as many tasks as you want with Airflow by choosing the right executable. Airflow has a user interface. This user interface provides you a task execution monitor for your data pipelines. And I will not give you more details at this point because we will see it later. And at the end, Airflow is extensibility. It means that you can extend the existing functionalities of Airflow. Okay, Airflow has five components. The first is the web server, the Flask server with Unicorn server, the UI. The web server provides access to the end user through the user interface. The other component is the scheduler. This component is in charge of scheduling your task, of scheduling your data pipelines. This is the heart of the Airflow. Another component is the metastore. This is a place where all the metadata of your data problems and your data pipelines will be stored. Usually here we use MySQL or Postgres DB, but it's nothing more than a database that you will connect. Executor. The executor is a class that defines how your task should be executed, in which system your tasks are going to be executed. And at the end, we have the worker. Worker is a process or some process where your task is effectively executed. Okay. And the next concept is about how Airflow works. In this part, we are going to explain how Airflow works. And Airflow work, or how the different components of Airflow work together. Let's begin with the simple architecture, this one. In this single node architecture, sorry, one node architecture is the simplest architecture. In this part, we are going to explain how Airflow work or how the different components of Airflow work together for this architecture. Let's begin with the simple architecture that is made up by one machine and different components of web server, scheduler, metastore, and executor. Well, now I will explain you how those components work together. First, the web server fetches some metadata from metastore of effort in order to display information corresponding to your DAG, your task instance, or your users on the interface. Next, the scheduler interacts with the metastore and execute and the executor in order to trigger the DAGs. Finally, the executor interact also with the metastore in order to update the task that just had been completed, executed. It's important to mention here that the executor has an internal queue. In this queue is really part of the executor because it defines how your tasks are executed in right order. And in the right side, we have another architecture, the multi-node architecture that is called Celery. Okay. This architecture is basically a way to process your task on multiple different machines. So let's see how the architecture looks like. First, we have one node with the components web server, scheduler, and executor. But this time you will have a second node where usually you will put the meta stored or meta database of Airflow and an external queue of the executor. And in this case, you will have write MQ, which will be used in order to speed your task among multiple machines. Those machines are worker 1, worker 2, or worker 3. In each of them, you will have an additional component called Airflow worker, where the task will be executed. Now, let's review the interactions between these components of the second architecture. Okay, the first interaction is between the web server and the metastore. The web server fetches some data from the metastore. Then you have the scheduler interacting with the executor and the meta stored. After that, the executor pushes the task into the external queue, and at the end, once the tasks are in the queue, they are pulled by the workers and more, and then the workers fetch the task from the queue. And so that is how it works. This is the way for execute multiple tasks on different machines. Okay, and now I'm going to explain you about what is a DAG. Directed acyclic graph. This graph works with node directed by node loops. This is the most important concept that you have to know when you are going to start working with Airflow. Basically, a DAG is a graph, how you can see here, with nodes and edges are direct, and more importantly, there is no loop. Let me show you the first graph that we have in the left side. It's a graph with 4 nodes. The for node is depending on the 1, 2, and 3 node to start his execution. The nodes number 1, 2, and 3 have the edge that start in each node and are pointed to the node number 4. Okay, this is a DAG. Now let's go to watch the graph that is located in the right side. This node is similar to the graph that is located in the left, But the only different thing is that the new graph has a node depending has a node 1 depending now of the for node, and it is a loop. It's very important that you keep in mind that the loops are not permitted in Airflow because this is a direct acyclic graph. If you try to do a loop in Airflow, you will get an error. Okay. Okay. What is an operator? This is the second concept. This is the second most important concept that you must know when you are working with Airflow. So you can think in an operator like a task, yes, or an object encapsulating the logic, the job that you want to execute. For example, in this image, you have a tag that contains some task that you need to execute. There are execute a Python function and execute a bash command and execute a SQL request. Each of them is an operator or a task. For execute each task, you must use the modules or libraries that contains those operators in the library. For example, the Python operator, the bash operator, and the Postgres operator. Every task that you want to create or execute in your DAG have a corresponding operator, and you can find the operators or more operators that you need in Airflow documentation. There are three types of operators. They are an action operator. This operator that allow you to execute something, for example, a Python function or a bash command. The other one is transfer. The transfer is an operator allow you transfer data from a source to destination. For example, MySQL or Postgres operator. This operator saves you time of implementation of logic to move the data between the source and destination by yourself. And at the end, we have the sensor. This operator allow you to wait for something to happen. For example, an event before moving to the next task. Or for example, if you want to wait for a file to land on a specific location in your file system. So every 60 seconds by default, the sensor operator will check if the corresponding finding the file that you are expecting exists or not. If just exists, then it move forward. If not, just wait for keep wait for the file. So with this operator, you can do a lot of things, complex data pipelines for DAX. And that's it. Okay, we are going to continue with another topic about Airflow UI. I'm going to show you quickly about the user interface of Airflow. We are going to do a quick tour of Airflow UI. Okay. But before to start with the tour, I want to make an important parenthesis here, and it is that from this moment on, I will be working with my Airflow installation in Docker locally, since the content of this video is totally to know the generalities of Airflow and create our DAG. Ideally, you should work with the version that you installed in the previous session using Terraform template in AWS Cloud. There are two components that you will be using a lot of to interact with Airflow. The first is the interface, and the second is the user interface. Okay, next I'm going to show you the most important views of the user interface. the first thing that I'm going to do is run Airflow from my Visual Studio, my Visual Code terminal. So let me open the Visual Studio. Okay, I'm going to open my Visual Studio Code, and here I have a project with a Docker file where I am configuring all my image to run Airflow. Okay, the next thing that I'm going to do is type here in the terminal docker compose app plus div plus build. Okay, we're going to app okay, and now he's running the instance in the Docker. I'm going to check Docker PS if my instance is up. As you can see, my instance is up now. So the next thing that I'm going to do is type in my browser, to open my browser, and we type here localhost colon 8080. Okay, well, once we enter the first view that we are going to see here, is the view where our DACs are located. Well, one of the options of that each DAC is a toggle button, which is used to pause or unpause your DAC. You must activate this button to execute your data pipeline, even if you are going to execute it manually. Then we have a name of the DAC. In this case is DAC insert data. And we have some tags inside the DAC. If we click here, we can associate some tags. Those tags are util to find our DAC with this control. Okay, I'm going to come back here and okay, we are going to explore the columns of this table. The first column has the name, the next column has the schedule, okay, and in this column we set the schedule interval. This is the time interval in which your DAC was executed. For example, once every day, or in this case none. Or you can set, for example, weekly or monthly. Yes, you had different options here to set the schedule of execution of your DAC. The next column is the owner. Okay, in this column we can see the owner of the DAC, or the responsible of this DAC, which is used for auditing purpose. For example, if we go to browser and click on logs, audit logs, you will see an audit log in which the owner of the DAC is registered and who was executed the DAC before. Okay, going to come back to the DAC, and we are going to review the next column, recent task. So we have the recent task column in which we are going to obtain the status of the task that are being executed in the currently active DAG. For example, we have the status success, success, running, failed, upstream, out for reschedule, skip, out for retry, and so on. Remember that here you will find the history of the executed task of your DAGs. The next column is the last run execution of your DAG. The other one is DAG runs. In this column, we will know and we will view and we will see the runs column on, or more specifically, the state of the diagrams or instances of your DAG that are running at a specific time. These states are success, running, or failed. Okay, the last column has different buttons, like for example, trigger your DAG manually, the tree view diagram, the graph view, task direction, task tiers, landing types, grand view diagram, the code of your DAG, logs, refresh the execution, and delete the DAG. Delete the DAG is only a button to delete the metadata of your DAG, but your code remains. And okay, well, now we are going to click in one of our DAGs, for example, in tutorial. Okay, and here we are going to see the tree view, which is very useful to see the history of our current diagram. Here you will see the status of all the tasks that you have executed and that have been executed before. If we turn on our DAG with the toggle button, and if we refresh the DAG, and we can see the status on the right side. You will have the summary of each task status means. For example, scheduled, skip, upstream failed, out for reschedule, out for retry, failed, success, running, queue, and no status. So this summary is very helpful tool to monitor the execution status of all your tasks. Okay, if for example we trigger our DAG manually, we can see this circle green, market green, and if we refresh here, we can see that this task finished successfully, and because there are the tasks are marked in color dark green. Okay, now we are going to click in the graph view, and here we will see a nice representation of our DAG with its tags and dependencies. And in this case, we don't have dependencies. We only have one task. We also have the summary of the states associated colors. It offers us an automated refresh button here. Now we are going to run again our DAG manually. I'm going to trigger the DAG, and we are going to come back to the graph view. And if we refresh, we can see the different states of our DAG, different colors. Now it's running. Okay, it's running now. And in this moment, the task finish success. And now I'm going to explore the grant view. In this task, we can see different things. Like for example, this diagram allows us to identify if your DAG has a bottleneck in some of its tasks. We can identify which rectangle of the graph, which tell us how long the task is taking too much time to finish it execute. This graph allows us to identify tasks too, the tasks that are executed in parallel, and that's it. Well, now I'm going to explore the code of my DAG here. This view is In this view, you will be able to validate the change you make in your DApp. It is a good practice that every time you make a change, you revert it in this view. So now if we click on any of the tasks of our diagram, I come back here, grab view. If we click here, we will see a submenu will pop up. Here we can have an access to some actions of our tasks. For example, we can obtain some details. Render, which inject a date at time once your DAG is executed. We also have a log of the execution. This is one of the most important action, since we can monitor and see the execution logs of our task. We can also verify the instances of the task. Finally, we have the task instance, and also we have some additional options such as run the task, ignoring dependencies, ignoring task state, or ignoring task depths. And another option is clear task, which help us to eliminate the current status of the task and allow us to retry the execution of the task. If we click on clear, then it okay, we will have the task ready for an execution retry. We can simulate, for example, the behavior of our task, mark as a failed or as a successfully. And okay, I'm going to close here. Finally, we can find different options here in browse, like for example, the task runs, the jobs, the task instances, and in the admin we can find the variables, the connections, the user, the configuration, and so on. And the views that I want to share are the most important. Some of their views we will discover later in this section. Okay, in this moment, I'm going to come back to the slides. So now we finish with the tour of UI. Now I'm going to show you a demonstration about how to load data from a CSV file to a Postgres database. We are going to create our first DAG, and we are going to run and debug our execution of the DAG. Okay. We are going to interacting with three tools. The first one is a bucket of Amazon S3 to store the CSV file. The second one is obviously Apache Airflow to orchestrate our data pipeline. And the last one is the Postgres SQL RDS. Okay, this is the design of our exercise. These are the steps. The first thing that we are going to do is create a bucket S3 and set up the user connection to set up the connection from Apache Airflow. Okay, so let's do that. The first thing that I'm going to do is open my console in AWS. It's important that in this point you have an account created, a free account. You will have a year free for AWS, and you will have some credit free. We are going to spend more or less $50 creating our services across the bootcamp. So you can work in AWS with your account free. Okay. So now I'm going to open the browser. I'm going to open my management console, and I'm going to start to create the bucket S3. The first thing that we have to do is search S3 here in the bar of searching of services, and select S3. We select S3. So remember that at this point, you must already have an AWS account created and have the infrastructure services deployed using the template Terraform that was provided in the before video. I'm going to create this service in manually way because it's important that you know that this method exists for you and it's available for everyone. So now click in create bucket, and the first thing that we have to do here is specify the name. I'm going to specify this name, bootcamp engineer airflow 2. Okay, it's important to mention here that this name is unique. This name is like a primary key and must not contain spaces or uppercase letters. So I'm going to let this region, it's fine for me. I'm going to block all public access, and I'm going to list this option by default. So click and create bucket, and the bucket is created successfully. Okay, the next step is create an user to set permission to this bucket. So we type here IAM, and we inside to the IAM, and now we select users, and we have a user created before. I'm going to create a new user based in this user. So click in add user. We have to specify again the name, the unique name. So I'm going to put the 2 at the end. Click on access key programmatic access to enable an access key ID and secret access key for the access through the Airflow connection. So click on next, and now we are going to attach existing policy. We need to set the permission to read objects to this user. So we have to create a new policy here. So click on create policy. And now the first thing that you have to do here is choose a service. We type here S3. We select S3. And in the action, we can select list and grid. And we are going to select the get object option, okay? And no more. That's the only thing. It's a good practice. Limit the functions for each user for security, okay? The next thing is select for my bucket here at the ARN. We have to specify the name of the bucket. Click on add, and the same thing for the object. ARN. We put the name, and the name of the object is okay. And select any for the object name. Click on add. Next, we're going to review the policy. Sorry, and we have to specify the name of the policy. So for my policy, I'm going to call this like read S3 source airflow 2. I'm going to put the same on the description. Create policy. Okay, I'm going to create a tree because already exists. Create. And now we have our policy created, successful. We are going to come back to the user creation here, and we are going to attach our new policy. We find S3, but first we refresh and type again S3, and now we have our policy here. We select our policy, sorry, and in this moment, okay, at this moment we have to select here use permission boundary to control maximum user permission, and we select our policy, and next tab, next, and create user. So our user had been created successfully. So now we have to download the CSV file with the access key ID and the secret access key. So I'm going to download this file, and I'm going to save this file in a folder that I know, because we are going to use these credentials later in our configuration about S3 in Apache Airflow. Okay, I'm going to save here courses, bootcamp demo. I'm going to put this here, the 2, and that's it. Okay, the next thing that we have to do now is create a connection here in Airflow. So we go to Airflow and click on admin and click on connections, and we can reuse the AWS default connection. So we edit this connection, we list the same name, we select the S3 type, and this is clear. And in the extra field, we have to type a JSON object with the key and value, two keys. The first key is AWS access key ID, and this is the value that I have in the file. I'm going to open the file here, the CSV file. So you can see this is the value and the secret access key. Okay, we copy the values and paste the values here, access key ID and secret access key. I'm going to close, save. I not save because I had this connection set up configuring before, so cancel. And that's it for our creation and configuration of our first component S3. I'm going to come back to the presentation to see our next step. The second step is create a database, AWS RDS, Postgres, SQL, manually. So this is optional. The first and the second step are optional because you are using the Terraform template now, but I'm doing this manually because it's important that you know that exists this other method, and that you can use. Okay. And now, okay, the important thing here is only create the user. You have to create the user connection that we created before to connect Apache Airflow with Amazon S3. And now we are going to create the database Postgres SQL, and there we are going to need the host, the admin user, the password, and we are going to do an additional configuration to connect Apache Airflow to RDS Postgres. Okay, so now I'm going to open my console again, and I'm going to type here RDS, and I select RDS. Okay, I'm going to create our PostgreSDB database. So click on databases, and I had been created a database for this exercise before, but I'm going to create a new one for this demo. Okay, so click on create database. We select Postgres SQL, the last version. Okay, we select dev or test. I'm going to write the name of the database. So let me see. This is well, but at the end I'm going to put 2, and I'm going to create a user connection. I'm going to put this, and the password I'm going to put the same. Okay, print the password, and here we are going to select the more cheaper instance because it is with purpose of academic, but for training. And for that, I'm going to select here for stable classes, and I'm going to select the most cheaper database, that is DB4 micro. Okay, and I'm going to list general purpose. 20 gigabytes is the minimum to storage. Enable storage auto scaling. Okay, and this is the price for the monthly cost for our database. So you can reduce this cost, stopping your instance when you are not using the database. Okay, so we are going to create the database. So click on create. So it will take more or less 5 or 10 minutes. So I'm going to pause this video, this part, while the process finish. Okay, the database has been created and the process finished. We have the status available, and here we can find the information about your database. This is the identifier, and here we are going to need the host to establish a connection with April. So we are going to copy this endpoint, and the port by default is 5432, and I'm going to check first that I have connectivity to my database. So I'm going to open my tool, my client pgadmin, to connect to my database from my machine. Okay, okay, I'm going to, right now I have a connection here. I'm going to click on properties, my database Postgres connection, and here I have the host name that we was copying in the connectivity and security title of our Postgres RDS in AWS. This is the port. Come back here. This is the port by default, and we type the username and we save the connection, and now we have the connection to our database, and I have an schema bootcamp db, and I have some tables that we are going to create in our exercise. Okay, I'm going to script to select, and as you can see here, I'm going to execute this command SQL, and as you can see, we have some data loaded in this table. So okay, well, we have connectivity, and the next step is create our connection here in Airflow. So for that, we are going to admin connections. We select Postgres default because we are going to reuse this configuration. We select here the pencil, We list the same connection ID. We select the Postgres type. We establish the host name. The schema is the name of our database. How you see here, the name of our database is Postgres, and the schemas are bootcamp, DB, and public. But here you have to put Postgres. Then you write the user, the password, and the port, and save. Okay, and the next thing that we are going to do is come back to our steps of our exercise. So the third step is read the CSV file from S3 to Airflow and return a pandas data frame. And now I'm going to show you the CSV file. So let me search the file. Okay, so Finder sample CSV. Okay, this is our source file, and we had 15 columns. This is a table of products. Here we have an information, and we have different kind of or types, data types. We have the strings, we have some float, we have dates, and that's it, and integers. Okay, so the first thing what we are going to do is going to Amazon and search our street bucket that we create. I'm going to inside and click on upload, and we are going to upload the file. Click on add file, and I'm going to select the folder where is my file. Courses, Airflow 2021, bootcamp, demo, sample. Open and click on upload. Okay, the file is upload succeeded, and right now we have our source, we have our bucket S3, we have our database, so we can start to programming or creating our first DAG in Visual Studio Code with Airflow. Okay, but before I'm going to explain you about something about new concept that is hook. We are going to create a hook that is very useful for us. Well, a hook is a high-level interface to an external platform that lets you quickly and easily talk to them without having to write low-level code that hits their API or user special libraries. They are also often the building blocks that operators are built out of. They integrate with connections to Gartner credentials, and many have a default connection ID. For example, Postgres hook automatically looks for the connection with a connection ID of Postgres default. If you don't pass one, you can view a full list of Airflow hooks in Airflow API documentation. Custom connections for hooks. Airflow allows to define custom connection types. This is what is described in detail in provider package. providers give you the capability of define your own connections. The connections custom can be done by anyone, any provider, but also many of provider managed by the community define custom connection types. The full list of all providers delivered by Apache Airflow community managed provider can be found in connectors. Now I'm going to open the Airflow documentation. So click on documentation, and here we have some providers packages. We are going to search, for example, an AWS or Amazon. Click on Amazon, and we have a list, connection types, operators. I'm going to search if we have some operator that we can use for the extraction our CSV file from S3 to PostgreSDB. As you can see, this is the list of operators that Airflow offers for Amazon AWS, and we have S3 to Redshift transfer operator, but we don't have an S3 to Postgres operator. So for that, I'm going to click on Python API, and the Python API provide us some hooks, and I'm going to search the S3 hooks, and we have these operators: S3 bucket, S3 copy objects, S3 delete objects, operators, sensor. But we need transfer from S3 to Postgres, and we don't have a package that exists for that purpose. Okay, so now the thing that we have to do is create our custom connection, our custom hook. So for that, I'm going to come back to the operators. So I'm going to take an operator that I see before. This operator is S3 to Redshift operator. So I'm going to open this operator, and I'm going to open the source, the code. And here we have a class that is inheriting from the base operator class. And here we have some code that it could be helpful for us. We are going to base in this code. So now the first thing that I'm going to do is open my Visual Studio. And here in Visual Studio, I have a project created before that is named Airflow Clean. And here I have a folder for my DAX. I have another folder for the custom modules that we are going to create. And we have the Docker Compose and the Docker file to deploy our Airflow in Docker. So right now I'm going to up my service with Docker. I'm going to leave this the template of this project in the resources of the bootcamp. So don't worry for that. If you want to replicate this example, you're going to have this repository in the resources of the bootcamp. The first thing that we have to do is create our DAG. And for that, I'm going to create a new file. So I'm going to call this dot data from S3. Okay, we now have our Python file for create our DAG. So the first thing that we are going to do is import Airflow. So we are going to import from Airflow, import DAG. Okay. And we are going to import some Airflow utilities like dates. Okay. And for now, that's it. So the first thing that we are going to do here in our DAG is create the default args. So for that, I'm going to create a variable that is called default args. And in this object, we are going to specify some parameters for the schedule and the execution of our DAG. First, I'm going to specify the owner. In this case, myself. So I'm going to put here Juan Escobar, and then I'm going to specify the dependencies on past. So for now, we don't have dependencies, and I'm going to specify the start date where this DAG going to start to execute it. Utils that dates that days ago. I put here 1 day ago because when you specify a date, this date start at 1 a.m. So if we put the current date when we start our Airflow UI, the DAG will not execute it automatically. Okay, so it's for that reason that I establish this date. Okay, so I can put my email. Okay. So right now I'm going to specify an example email, and we can specify if we are going to notify it in case of failure. So for that, we can to put here email on failure equals true, and then we are going to specify the retry in case of the failure. Retry only 1 time, and a delay for the retry that in my case it will be 5 minutes. So retry delay time delta minutes equals 5. Okay, and for now, that's it. The next thing is declare a bar for create our DAG. So I'm going to change here the library. So here I'm going to pass the parameters. The first is the name of our DAG. I'm going to call this like a DAG insert data Postgres. Okay, so I'm going to specify the default args equals default args, the same, and the schedule interval I'm going to specify only once. Okay, and right now I'm going to create my first operator. So I'm going to call this process data. Okay, process data equals, and I'm going to comment this line because first we have to create our custom operator, and for that we are going to open custom models and we are going to create a new file, and we are call this file like DAG s3 to post, sorry, rename to Postgres table dot pg. Okay, and the next thing that we are going to do here is open the source that we have for S3 to Redshift operator, and we are going to copy this code. We are going to paste this code here, and now we going to start to organizing this code. I'm going to delete these docs, place, and I'm going to delete this comment, and I'm going to change this name from Redshift to Postgres. Okay, so it's a best practice to have the comment in our code, but for this exercise I'm going to delete because it's too much. Okay, here we have the constructor of our operator, and we are going to use some parameters, and another parameters we are going to delete. I'm going to replace the name of the class here because I changed the name, and this is the method that execute the operation or our task, that it will be extract data from our S3. Remember that we have the steps here. We are creating our custom operator to extract or read the information from our CSV file, and then we are going to create a function to create a table with SQL command with Postgres operator. And after that, we are going to create a function to insert data into the table previously created using the return of the function as a parameter. And let's go. Okay. So first, I'm going to check these parameters because I don't need some parameters. I'm going to replace here Redshift default because we are using now Postgres default and AWS default for S3. Okay, so schema table S3 key is the name of our file. We need this, we need the schema. This is the name of the database that we are going to create in Postgres. The table is the name of the table where we are going to insert our values. The name of our bucket S3 where we saved our CSV file. S3 key is a parameter for the name of our CSV file. I'm going to change this name because our database is not Redshift. Our database is Postgres. So I'm going to replace this value here from Redshift to Postgres. So replace and verify. And I don't remember for what is this parameter. For now, I'm going to let this parameter. Okay, so let's continue with our exercise. I'm going to delete this code because we are going to create our DAG. So we are using the base operator. I'm going to inside to the base operator. And here we have different methods. Like for example, so we have too much methods here. So the first thing that we are going to do here in the self function is that we are going to create a connection with our street bucket. For that, we are going to use the scope of our class. It is self. Okay. We are going to use a PG hook, but first we have to create the reference for this library. I'm going to copy the reference here. I'm going to paste the reference, and now we are going to create an instance for the Postgres hook, and we have to pass the parameter of the Postgres con ID that is equals to self that Postgres con ID. Yes. And the other parameter is our connection from AWS. sorry, here is only one parameter, that is the name of the connection ID. And now we have an instance of our database here. We are going to create another instance, self.string, where we are going to use a string hook, and we are going to pass the same, the AWS con ID here is equals to self that AWS con ID, and the other parameter here is verify, well, self that verify. Okay, now for informat in the console terminal, I'm going to print here self that log that info that we are going to start to downloading S3 file. Okay, and the next thing that we have to do is validate if this file exists or not in our bucket. So for that, I'm going to write here a condition that is the next self that string that check wildcard key. Okay, so I'm going to pass the key self that key s3 key, and I'm going to pass the bucket name to the validation self that s3 that bucket, sorry, self as bucket name. Okay, and if this is true, so we have to raise an error. I'm going to import a module Airflow exceptions to catch the exception here about no key match. Okay, so I'm going to put the raise exception here. Is if we don't find the file, we have to raise exception for the DAC. Okay, no key match with this name in our bucket. But in this case, we have to get our string object. We are going to create a variable that is a string key object that is equal to the scope that string that get wildcard key and that receive the parameter string key and string bucket. Okay. Okay. So, but I forgot something, and I have to put here this because we are going to do this validation only if this value is in true. So I'm going to create that value, there verify here, and I'm going to init this in false, and here after verify I'm going to assign the value, sorry, equals same bar. Okay. And here I'm going to continue with the condition. Here I'm going to put the else, and I'm going to validate if not so s3 check for key. And I'm going to pass the self that s3 key and self that the bucket name. Okay. And now we have to raise an error if we don't find the file in our bucket. Okay. And at the end, we have to get our object s3, that is our CSV file. And after that, we have to create a list of strings. So here I'm going to put this. List of strings is equal to a street key object that get reference body and read and decode this file with UTF-8 and ignoring errors. Okay. So the next thing that we have to do is define our schema for our table. So I'm going to define a variable that is called schema, and I'm going to save here a dictionary with our columns and their data types. And as you can see, we have a product that is type string. We have a presentation that is type strip, marca, categoría, catálogo, price, that is float, cadena comercial, giro, name commercial, direction, state, municipio, latitude, and longitude. Okay, that are floats. We have strings, floats, and we have another column that is type, date, fecha, registro. Okay, so the next step here is create a data frame. So I'm going to create a variable df product equals to, we have to use pandas here, from pandas as PD, sorry, from pandas, yes, as PD, sorry, import pandas as PD, yes, that's the way. And here we are going to use the module pandas that, and we are going to read CSV file, and we are going to pass parameters to read this CSV file that we assigned in this variable before. So we have to use the IO library. So we are going to import IO here. And in this parameter, we're going to type io dot string io, and this class will receive a list string of the content of our object string. Okay, so the next parameter here is the headers. Header is equal position 0, because our file has the headers in the first row, and we have a delimiter equals to comma, and the quote char is equals to double quote and comma, and here we're going to put low memory use equal to false, because we have considerable number of register in our file. And at the end, we are going to specify the data types that is equal to the schema. Okay, and that's it for read our CSV file and convert our CSV file into a data frame. A data frame is like a table in memory, and now that we have this table in memory, we can to manipulate the data in our code. Okay, so I'm going to specify here the name of the file. No, first we are going to create a file, like, let me close this. Here in custom models, I have a folder access, and here I create a file with the SQL sentence DDL, or create the table in our database. So you can do the same, and for read this file, I'm going to do the next thing. So here I'm going to specify the name of the file that we are going to read. The name of the file is equals to bootcamp ev products.sql. Okay, I'm going to specify the path file here is equals to user local Airflow custom models and assets plus OS that I have to import OS import OS and we are going to use OS path.sep. This is a separator of the operating system that is executing our DAC. Okay, so here we are going to concatenate our name file. Okay, so the next step here is open this file. So okay, I have to explain you something before to continue. This path, I took this path because here in my Docker file, sorry, in my Docker Compose, I have some paths are configured for synchronize my local path with the Docker path. Okay, it's important that you specify, for example, the path for the DAX or for the custom modules. In this case, is equal to user, local airflow, and custom modules. And for the DAX, is user, local airflow, DAX. Okay. Now we can continue with the next part. We are going to open the file using with open, and here we are going to pass the file path, and okay, we have to specify here another variables, like for example the encode, yes. In this case, my file has a UTF-8 encoding. Okay, so the purpose of my operation with open is only read, so we have to set here R, and okay, I come back here in code, file path, and the purpose of the file first. So then we have to specify the encode equals to encode. Sorry, encoding equals to encode, and I'm going to set the name of the file SQL and here I'm going to put this code to copy this code, and I'm going to replace here this bar. So here we are reading our file, and we are saving all the content of our file in this variable SQL command file table. And now then we are displaying or printing the content of this file in the console. Okay, the next part is execute our SQL creation of the table, our DDL sentence here. So for that, we have to use the object pg hook, yes, run this command. Okay, so now we have a table created, so we can continue with the other part. The other part is defined the list of our fields that we are going to insert in our table. So it's important that you see this. The first field is the ID and is serial. And when you define a serial kind type, the value is optional to insert. You can't not pass this value. For that, I am specifying all fields here list ID. Okay. Okay, here we are going to continue creating our code, and for that I'm going to create a var self that current table equals to self that schema that we passed before in the constructor, and we are going to concatenate that self the table name. Okay, and now we are going to insert the rows. So using our self.pg hook that insert rows, the first parameter is the self that current table. The second parameter here is the list target fields. The other one is here is the list of the F products, and then we have to specify the target fields. Target fields equals self. Here is self that target fields. Okay. Put here this value. And we are going to specify a commit every 1000 of records and replace equals false. Okay. And the last step here for our operator is create a sentence to query our fields, our values that we insert into the Postgres database. So for that, I'm going to create a var that I'm going to call request equals select all from plus self that current table. Okay, and I have to open the connection. Equals self that pg hook that get con, and we have the connection now. So we have to set the cursor and self that pg hook, sorry, self that connection that cursor, okay, and self that cursor that execute self request self that source equals self that cursor that fetch all. Okay, so now we have the source, we have the result in this source of the fetch all values of the table products. So we are going to print those values with the next sentence. We are going to create a for source or row in self that source equals self that log that info, and here I'm going to copy and paste this code for print the values of our products. I'm going to use here the format function. I'm going to paste the values like this, and I'm going to replace this bar row for source, and that's it. Okay, we finish in this moment our Houston operator S3 to Postgres. So now we are going to complete our DAG. So I'm going to uncomment this bar process data, and I'm going to pass the parameters for, but first I'm going to, we have to import from the Houston modules that DAG S3 to Postgres. We are going to import our S3. So let me see, import S3 Postgres router. Okay, I'm going to use this class, the operator, and we have to pass all the parameters that this class in his constructor need. The first one is task ID, that is equals to DAG S3 to Postgres. Okay, and the other one is the schema. Remember that the schema is our schema that we create before in our Postgres database, that is called bootcamp db. The other parameter is the table name, that is equals to products The other parameter here is the S3 bucket that we called bootcamp WL engineer airflow. Okay, we have to set the other parameter that is S3E. This parameter is the name of our file. I call this like a products.csv, and the connection, the ID connection, AWS can Postgres ID is equal to Postgres default. The other one is AWS con ID is equals to AWS default. Okay, and the last parameter is DAC equal to DAC, and that's it. Okay, that's it. This is our DAC. So now I'm going to up my Airflow in Docker. So for that, I had to write here Docker compose app let's build. So click it. So enter. And I'm going to type Docker yes. And we can see that our instance is up 55 minutes ago. And okay. Okay, now I'm going to open my browser and I'm going to turn on my DAC for the execution, and I'm going to trigger this DAC manually. Click and trigger, and I'm going to inside into the tree view. Here, the DAC is running, and I'm going to refresh. So we have the first task or operator of our DAC S3 to Postgres that is running right now. I'm going to refresh again, and we are seeing that our operator is running again. So let's wait for a moment, and we are going to see the final state. So how you can see, the task finally success with the color dark green, and we are going to see the log. So in the log we can see the information about our table here, and other things, like for example our DDL statement to create our table, the schema of our table, the data types, strings, floats, the object for our date, and another floats. And at the end, we can see all the records here. And that's it for this exercise. Okay, now we are going to continue with the presentation. We're going to move to the another topic, good practices and tips. So I'm going to start with the Apache Airflow best practices. So the first best practice is writing better DAGs. So before creating a DAG, you should think carefully about what you do expect from it. Here are some questions that you can help. Where is input? Where is the output? When should it be triggered? At which interval of time? What are three parts tools it will interact with? What will be tasks? This is very important. Can make it simpler. The last question is important. Always ask yourself if you really need to build a DAC to achieve what you want, or is there any other solution that could be easier to build and maintain. Do not overcomplicate your data pipeline. That should have a clear purpose, like exporting data into your data warehouse or updating your machine learning model in production when needed. Okay. Another best practice is defining a clear purpose for your task. So we have to have a clear idea of tasks you want to execute through DAC. Try as many possible to have one task, one job, and no one task, multiple jobs, like for example here. Let me give you an example like this. In the left image, we have too much task, like for example, cleaning, transformation, validation. And in the right side, we have different operators and tools with the independent task, sorry. Okay. As shown in the example, it is tempting to put everything in Python operator, but I strongly advise against it. Let's say the function validating fails, where areas wrangling, cleaning, transforming succeeded because only one function fails. Therefore, consider the whole task as a failure. So instead of retrying only one task, all the functions are retried as you put all the work into one task, like in this example. That's why you should have one task, one job, or one task, one operator, so that if something fails, only this part will be executed again and not the others. This will prevent from inconsistencies in your data and will make easier to spot what fails and why. Okay. DAX and Context Manager. In Python, you can leverage Context Manager to allocate and release resources precisely when you want to. The most widely used context manage is with. The with statement makes the code cleaner by removing the needs of assigning the variable DAG to each task. By doing this, we can clearly see the tasks belonging to the DAG. If you have Python function in your DAG file, things can quickly become messy, and we let the context manager dealing with DAG lifecycle. Okay. And the other best practice is have the unique identifier or DAG ID. When you initiate, when you instantiate your DAG object, you have to specify the DAG ID. This DAG ID must be unique across all of your DAGs. You should never have two DAGs with the same DAG ID. Otherwise, only one DAG will show up and you might get unexpected behaviors. Define a meaningful DAG ID along with a description of your DAG. Think of when you will have hundreds of different DAGs. You definitely want meaningful DAX ID and description to quickly know which DAX does what. One more thing, in case you have multiple DAX, more or less related to each other, put in a common prefix for all of them can be a great idea. Okay, and the last one is the start date. This is a big topic here. The way DAGs are scheduled in Airflow can be somewhat difficult to understand at the beginning. The start date defines the date which your DAG will start begin scheduled. One thing you have to know is that each task or operator can have different start date. Yes, tasks with the same DAG can start at different dates. I strongly advise you, again, do not define different start dates. Keep things simple and homogeneous. I don't ever see a use case where you might need to do that. Okay. In addition, your start date should be static, no defined dynamic start date with a function like datetime now, as it is confusing. Keep in mind that tasks are executed once the start date plus scheduled interval spaced. If the start date is set to now, in theory, your task will never get executed as date constantly moved forward. Okay? And in conclusion, I hope you already learn new best practices. Obviously, there are many others Apache Airflow best practices to discover, and I hope this application has helped you to continue on learning path with Apache Airflow. It was a pleasure.